In this tutorial, we are going to demonstrate how to translate a polygon on the coordinate plane. Another term for translating an object is to slide an object. When we translate or slide an object on the coordinate plane, we can move that object either left or right, which is a movement in the x direction, or up and down, which is a movement in the y. And make 9 jumps in the x direction and 4 jumps downwards in the y direction, and then plot your new point. For example, if we put our pencil on point B, we can make 9 jumps to the right and 4 jumps down, and then record the new location of point B. We can do the same thing for point C and point A. After that, we can connect our 3 vertices and see that we have a triangle which is congruent to the original. One thing that should be noted with any translation is that the new shape should be congruent to the original shape. If it is not congruent to the original, then 1 or more points must be plotted in the incorrect location.
We have a triangle ABC that we have to reflect across the y-axis. There's a couple of different methods for achieving this. One method is to simply use the coordinate plane itself to do the reflection. Before reflecting this object across the y-axis, let's make sure we first know where the y-axis is. On a coordinate plane, the y-axis is the line which goes up and down. We must make sure that our object is reflected across that line. Now, let's take a look at point C. Notice that point C is exactly 4 units to the left of the y-axis. So just take point C and move it 4 units to the right of the y-axis. That's the new location of point C. Point B is located 4 units to the left of the y-axis as well. So make sure to do the opposite and move it 4 units to the right of the y-axis. Take a look at point A. Point A is located 7 units to the left of the y-axis. So let's simply move it 7 units to the right of the y-axis. And we have found the 3 new locations of point A, B, and C to reflect it across the y-axis. Now, let's write down the ordered pairs of the new points. Point A is located at +7, -6. Point B is located at +4, -6. And point C is located at +4, -2.
In geometry, we call a rotation a change in orientation. Note that a rotation is not a change in size, and that rotation should not be confused with reflections. Now we are going to reference 2 directions for rotations. Clockwise rotations move the same way that the clock does, and counterclockwise rotations just move in the opposite direction that the hand of a clock would normally move. Now, in addition to the direction of a rotation, either clockwise or counterclockwise, we are also going to reference rotations in terms of degrees. Just like this circular record, we're moving in a circular rotation, so our degrees are going to be between 0 and 360. Now, a positive degree of rotation is a counterclockwise movement. So we start with a figure, and making 1/4 turn is equivalent to a 90-degree rotation. A second quarter turn is adding another 90 to that, and 90 plus 90 equals 180, so this would be a 180-degree rotation. A third quarter turn would be adding another 90, this would be a 270-degree rotation. And a final quarter turn brings the figure back to where it started and completes the full 360 degrees.